Hello everyone, this is Prakash Kumar, and in this video I am going to talk about the parallel simulation in OpenFOAM and how it can be used to speeding up the calculation. So initially I have opened a wing motion case from the tutorial of OpenFOAM. Then you have to open it in a editing software. For that purpose I am using the VS Code. There are three different files predefined in the tutorial. Those are snappy hex mesh, steady case, and the transient case. For our purpose, we are going to use the transient only. There is an important file in this system folder that is called the decompose pardict. This is the main file that defines the parallel simulation in OpenFOAM. For my computer, there are 6 cores that I have. So in the number of subdomains, I defined it as 6. The method I have chosen is simple. There are 4 different methods in OpenFOAM. It is properly given in the documentation from OpenFOAM. I will provide the link in the description below. A brief description about the simple method that I'm going to use is it has been used for defining different directions for the simulation. For my case, I am using 3 cores in the X direction, 2 in the Y direction, and 1 in the Z direction. So now I'll start the simulation by opening the wing motion tutorial in my terminal. After entering the terminal, I will directly go to my transient folder. For parallel simulation, there are 3 main commands that we have to define. Those are given in the file that I have made. The link I'll provide it in the description below. First command is the decompose pair. This is where I divide my files for running into the 6 different cores. As you can see, all the files have been subdivided into 6 cores, namely starting from 0, processor 0, ending with processor 5th. You can also see the same file being created in the transient folder. Every core files has 2 subfolders that are 0 and constant with the defining conditions. For running it in all the different cores, there is a command which starts with mpi run. Number of processor, for my case I'll define it as 6. Home run, and as we are running it in parallel, so parallel. I want to write this file in a folder called test, so I'll define it using command. So our simulation has been started. The results in the terminal are also written down in my test log file that I have created. I'll let it run for some time and then I'll show you how to recombine the results. I have stopped the run after an iteration of 0.19. As you can see, the same thing had been written in my test log file. In all the different processor files, the result had been written from 0 to 0.19. Now we have to combine it together to see a proper visual of the result that we have got. For that, we use the command reconstruct pair. This command combines all the result and writes it into one folder. As you can see, I have files from 0 to 0.19 in my main transient folder. To view the result in ParaView, I will use the following command. So this was my simulation combined as a whole that I've done through parallel simulation. This is very useful for significantly decreasing the time of simulation using parallel processor of your computer.